Matt,
What? No.
you're gonna need to be doing something else if you want to pass this class.
Is there any way I can earn some extra credit?
I mean, yeah, I can tutor you this afternoon. Just show up at 2:30.
Alright, see you there. Sorry, I'm a little late.
Yeah, a little late. It's been like 20 minutes. The reason I called you here was so that we can talk about the concepts of work, energy, and power with examples you can even find in your own house. First, let's talk about work. Work is when you move another object with a certain amount of force. You perform work when you move an object, like I previously said, or when you transfer energy.
Well, I already know that.
If you already knew that, you wouldn't have failed your test. Luckily, I have it so we can go over the question that you got right. John is pushing a car. The car isn't moving anywhere, but John is exerting force. What work is John doing? You put work equals force times distance, which is the right equation, but since there is no distance, the answer is 0.
I don't
So,
even know
you
what
got
to
it
do
wrong.
with this. Like, what do you
Obviously, by the fact that you did that, but I'll explain the basics for you. The best way I know how to do this is with real world examples. Let's go outside. So Tomato is trying to push the car with a lot of force, but is the car going anywhere?
No.
So we know that the displacement of the car is 0. We can multiply the force times 0 to get the total work. What would that be?
0?
Yes. What were you thinking on your test?
I didn't know the force that the person was putting on the car.
Well, you don't need to know the force because the car isn't going anywhere.
Oh.
First, let's talk about conservation of energy. Energy is always conserved. You need to remember that. Energy can be kind of lost in the equation, but it's just converted into something else. You know what potential and kinetic energy is, right?
Yeah, I think so.
Okay, well to understand this, we should probably get a real example. Tomato! If Tomato has a pencil and he drops it at a height of 1 meter, the potential energy should equal the kinetic energy. This is due to the conservation of energy. Now let's take a look at Tomato drop this pencil. Alright, so for this equation, the potential energy at the top, which is equal to mass times gravitational acceleration times height, will be equal to the kinetic energy at the bottom, which is equal to 1/2 mass times velocity squared. So when you set these two equal to each other, mgh is equal to 1/2 mv squared. There's an m on each side, so you can divide the whole thing by m, and then you have gh equals 1/2 v squared. And the question was asking for the final velocity. So you want to set this side equal to v. So first, you multiply both sides by 2. So you have 2gh equals v squared, and then you square root both sides. So v is equal to the square root of 2gh. So from the problem on the test, what height was it dropped from?
10 meters.
Alright, so v equals the square root of 2 times 9.8, which is the constant for acceleration, and 10 meters. So when you multiply this out, v equals 19.
196.
Sure with that? You know what the answer is?
14.
The next concept is power. Power is the rate that work is done, which is represented by power equals work over time. You think you got that?
I think so, but I think I need Tomato to explain it to me.
Not a bad idea for once. Tomato! We will watch how Tomato moves the chair from point A to point B. Let's assume that Tomato is applying the force of 100 newtons horizontally, and it takes 5 seconds to move from point A to point B.
1, 2, 3, 4, 5.
Alright, so the formula for power is the formula for work over time. Work is equal to force times distance over time. You think you can handle that?
I think I can take this from you.
So power equals work over time. So that means power equals force times distance over time. So if we plug in our equations, power would be equal to 100 newtons times 3 meters over 5 seconds. And that turns into 300 over 5, which equals 60, and the unit is watts for power.
That actually wasn't a bad job. I think you're getting the hang of most of this. Now let's go back to the question about kinetic and potential energy. There's another question on the test that just asked about what the value of a system's kinetic energy was. Do you remember what the equation for kinetic energy is?
I think I forgot.
If you would have done your notes and listened to me and Dan Fullerton, you would have known that it was 1/2 mv squared. Now let's go outside and do this equation. Alright, so we need to look at the equation for kinetic energy, 1/2 mv squared. So we know that the car's mass was 2,050 kilograms. Let's say its velocity was roughly 8.9 meters per second.
Yeah.
What would the energy be?
81,190 joules.
That sounds about right. All right, we're on the last concept, gravitational potential energy. This is the energy that an object possesses. Basically, what it could do. You get that?
I guess so.
Tomato! All right. Tomato is holding a box, which is roughly 1 kilogram, and it is about 1.5 meters above the ground. What is the formula again?
MGH, right?
Correct. Now, since mass is equal to 1 kilogram, G is equal to 9.8, and height is equal to 1.5, calculate the potential energy.
14.7
14.7.
joules.
There you go. That's the last of everything. Hopefully, on your next test, you won't fail and get a total 0.
Thanks, Mr. Z. Bye.